Today we'll be discussing lesson 95, which goes back to our equations of circles that we talked about around lesson 75, I believe it was. And there's two concepts that we're going to talk about with our circles today. You can see those in the title of the lesson. We're going to talk about how to correctly translate a circle and also how to correctly dilate a circle. Those were two of the transformations that we learned about earlier this year. Let's remind ourselves from lesson 75, what was the correct equation of a circle? Its radius was r, and its center was located at h, k. The equation that we saw back in that lesson was x minus h squared plus y minus k squared is equal to r squared. Again, the h and the k represent the center of the circle, then the r represented the radius. Now, something that we saw back in lesson 75, and the same thing is true today in our question. The center is the opposite of what is inside of the parenthesis. So if they tell me that the center is located at 2, negative 3, well, then my first parenthesis would say x minus 2, because my ordered there said positive 2. Then the second parenthesis would say y plus 3, because in the ordered pair, I had a negative 3 that went with the y. Again, you were only replacing the h and the k. What a couple of you did in the previous lesson was you replaced the x and the y. Don't do that. Those represent all of the points that are on the circle. We're just giving the center for the h and the k. So the opposite end for those two letters, the radius just goes on the right-hand side. That was called the standard format of our circle. Well, there's two things that we're looking at with regard to our circle today, and the first one was a translation. The translation was one of the first transformations that we talked about in class, and what did a translation do? It took every single point that was on our shape and it slid it so many spaces, either right, left, up, or down, or maybe in a couple different directions. So it slides every point of my figure the same distance in the same direction. Well, we're to do the same thing with our circle. We have some circle that is given to us on the Cartesian plane or even just the equation, and we need to slide the circle so that way we can write the equation of the new circle that we have. Now, how are we going to correctly translate a circle? Here's the steps that I would like us to follow. To correctly translate our circles in the lesson, they're going to give us an equation to start with. So from that equation, you need to go ahead and identify the center. The center, again, is the opposite of what you see inside of the parentheses. Go ahead and translate the center. So move it left, right, up, or down, whatever is necessary. Remember, the first number, that would be the h, that affects the x direction, so that would either go left or right. The k affects the y direction, so you would affect that number going up and down. Once you've translated the center, you're going to write your equation at the new center of your question. Our job will be to write the new equation, then we're going to graph both circles on the same Cartesian plane. That way we can see, okay, here's my original circle, and then here's the new circle after I've translated so many spaces. Now, listen carefully. Something that is true about a translation, it does not affect the radius. If the original circle has a radius of 5, the translated circle also has a radius of 5. You are not changing the size of the shape. All that you are changing is where it's located, which only affects the center. So notice what I just told you on that previous slide. You identify the original center that's given to you, apply the translation to it. Once you know the new center, you already have the radius because nothing's happening to it. So you can go ahead and correctly write your equation like I showed you on the first slide, and that x minus h squared plus y minus k squared equals r squared format. So let's work through an example together. The equation of my original circle is given as x minus 7 squared plus y plus 3 squared is equal to 36. Our goal is we're going to translate our circle 5 units left and 3 units up. After we do that, we're going to write the equation of the new circle, and then we're going to sketch them both on the same coordinate or Cartesian plane so we can see here's the original circle, here's the new circle that I have. So what steps are we going to follow? Number 1, let's go ahead and identify the center that we have in our circle. The center comes from the parentheses, but I'm picking the opposite of those numbers. So what do I see inside the first parenthesis? Minus 7, so I'm going to use positive 7. In the second parenthesis, I see +3, so I'm going to do a -3 in the question. Now, something that helps me as well when I'm writing down the original center, I also write down the original radius. Well, the radius came from the right-hand side, and that was the number 36. But the right-hand side says r squared. So what did I square to get a 36? It is 6. So that would be our radius. So the original center, we just noted, was 7, -3, the opposite of the parentheses, and my original radius was 6. Well, what translation, what sliding are we supposed to apply? The directions told me to take the circle and translate 5 units left and 3 units up. Well, going left affects the x direction. What number is the x here? It is 7. Now, because I'm going left, that's in the negative direction, so I took the 7 minus the 5. The second translation that it wanted me to do was 3 units up. Well, going up is in the y direction. The original y was -3. So I did -3 plus 3. So that's the work that I have inside of the parenthesis. Then I did the arithmetic. So 7 minus 5 was 2, and -3 plus 3 is 0. So the new center after we've translated is at 2, 0. Now remember, when we translate, it does not affect the radius. So my new radius is the same as the original radius. It's still 6 in the question. I have the center, I have the radius, so we can go ahead and write our equation. What does that equation look like? Again, we're putting the opposite inside of our parenthesis. So my first parenthesis would say x minus 2 squared. Now, notice the y that I would be putting here is 0, so it would say y minus 0 squared, but minus 0 doesn't do anything, so I just left it as y squared. So I have the parenthesis, x minus 2 squared for the opposite, plus y squared, because that just matched up with 0, and then the radius squared, so 6 squared was equal to 36. Notice the right side of this equation is the same as the right side of the original equation because the radius is not affected when we're doing translations. We are only affecting the center of our circle. Well, let's go ahead and look at them on the Cartesian plane. The original circle had a radius, or had a center of 7, -3. Now on my Cartesian plane paper here, because I didn't have enough space, I'm counting by 2's on each of the lines. So there's my center. I went right 7 and then down 3, and the radius was 6. So I moved up 6, which technically is 3 because I'm counting by 2's. There is my original circle. The new circle had a center now at 2, 0. So I'm just going to shift 1 space because I'm counting by 2's. And the radius was still the same. It was 6. But because I'm counting by 2's, I'm really only moving 3 in each of our directions. The green was my original circle. The blue is my new circle after I've translated so many spaces left and also so many spaces up in our question. So pretty easy to translate. We only affect the center when we're translating in our question. Let's move to the second thing that we're going to talk about in our lesson with regard to circles, and it's an idea with a dilation. What does it mean to dilate something? As we saw, I think it was in lesson 84, where we talked about dilations. It was a transformation that changes the size of the shape, but it doesn't change the shape. It was a circle. It's still a circle. What does happen to it? You had a bigger circle, and now you have a smaller circle in our question. So in our dilation that we're going to see for the circle, we'll notice the same thing is happening. We have one original big circle, and then we have another circle that's going to be a smaller circle, or maybe the original one was the smaller one, and now the dilated one will be the bigger one in our question. When it came to a dilation, we had a scale factor. The scale factor is what you multiplied by each one of the coordinates to come up with the new coordinate that you had in your picture. Now, how do we do that when it comes to a circle? As we're dilating a circle, it is not practical to dilate every single point. Because remember, a circle is just a round shape and is made up of an infinite number of points there. So I do not want to dilate an infinite number of points. So how do I correctly follow this process of dilating a circle? I'm going to, number 1, apply the dilation to the original radius. Notice the dilation does affect the radius. The translation that we already talked about did not affect the radius. Number 2, I'm going to apply the dilation to the center. So a dilation affects both pieces of our circle. The center, just like it did for the translation, but it also affects the radius as we're doing our questions. Once I've identified the new radius and the new center, then we can correctly write our equation, which is our goal. So let's work through a couple examples together. The equation of my original circle is x squared plus y squared is equal to 16. We're going to apply a dilation. It's still centered at the origin, like we talked about in lesson 84, and my scale factor is 3. So my new circle is going to be 3 times as big as the original circle. We need to write the equation of this new circle, and then we're going to sketch them again on the coordinate or on the Cartesian plane. So let's take a look at the original equation. X squared plus y squared is equal to 16. Now, notice on the side with the x squared and y squared, I don't have any parentheses. So what numbers were technically with the x and the y, if I didn't have parentheses, it would have just been 0. So this circle is centered at the origin. So the center of the original circle is 0, 0. What was the radius of the original circle? Well, on the equation, it equaled 16. So what do I square to get to a 16? It is 4. The original radius is going to be the number 4. Now that we know the original center and we know the original radius, we can correctly apply the dilation now in the question. The dilation was a scale factor of 3. The dilation applies to both of these pieces, the center and the radius. Well, how did we do a dilation? It was either a multiplication or a division. Since the number is just 3, then I'm multiplying by 3. Well, the center is 0, 0. 0 times 3 is still 0, and 0 times 3 is still 0. So the new center is still located at 0, 0. So please don't think, oh, the dilation doesn't affect the center. It does, but because the center is at 0, 0, nothing's happening when I multiply by 3. The original radius was 4. Well, that's going to get multiplied by 3. So 4 times 3, it tells me the new radius is 12 in our question. Now that I know the center and I know the radius, we can write the equation. As we write the equation, the opposite is going into the parentheses. But again, the center is located at 0, 0, so I don't have any numbers to put into the parentheses, so I just said x squared plus y squared. The right-hand side, I need to take the radius and I squared it. So 12 squared is equal to 144. Notice I did not take the number from the original question, which was 16, and multiply it by 3. I didn't do 16 times 3 to make 48. You had to find the original radius, apply the dilation, and then square it to put it back into the equation for what you're trying to write. Let's go ahead and look at these pieces on the Cartesian plane so we can see what's happening. The original circle was centered at the origin and it had a radius of 4. Again, to make everything fit on my picture, I'm counting by 2s like I did the last time. So I went right 2, left 2, up 2, and down 2. Now I'm going to draw out the new dilated circle. The new circle was still located, its center was at the origin, and now its radius is 12. So again, because I'm counting by 2s, I'm going to move 6 spaces in every single direction. Notice my blue circle is way bigger than my original green circle because it's been dilated by a factor of 3. It's 3 times as big as the original picture that we had. Let's try one more example together here. This one, the center is not 0, 0, so you can see how it affects the center as well. So the equation of my original circle is x minus 4 squared plus y minus 5 squared is equal to 16. We're going to apply a dilation, again, centered at the origin. That's always the same phrase we're going to see on these questions. Centered at the origin, and this time the scale factor is 1/2. So the new circle is half as big as the original circle. Our job, we're going to write the equation for the new circle, and then again, we'll sketch them both on the Cartesian plane. Well, to correctly apply the dilation, I need to know the original center and the original radius. The original center is the opposite of my parentheses, so I would say positive 4 and positive 5. That would be the original center that I had in the question. Well, what was on the right side of the original equation? 16. What did I square to get to a 16? It was 4. So the original radius on my question is 4. The scale factor that was given to us on this question is 1/2. So I'm going to take that 1/2 and apply it to every single part that I have here on the question, beginning with the center. 1/2 of 4 is 2, and then 1/2 of 5 is 2.5. So that one didn't turn out evenly, so I just turned it into a decimal there. I also need to apply the dilation to the radius. The original radius was 4. The scale factor is 1/2. So 1/2 of 4 tells me the new radius is 2 in our question. Now that I know the center and I know the radius, we can write our equation. As we write the equation again, don't forget, put the opposite into your parentheses. So I have x minus 2 squared plus y minus 2.5 squared. And then on the right side, my radius squared, so 2 squared is 4. Notice it was not as easy as I just took the radius, I saw 16 and I divided it by 2 to make 8. That is not what you want to do. Find the original center, find the original radius, correctly apply your dilation, then you can write the equation that you have. So let's finish up by taking a look at what did this picture look like. The original circle, its center was 4, 5, so I was able to count by ones this time. So I went right 4 and up 5, and its radius was 4. So I went up 4, right 4, down 4, and left 4. The new circle, its center was at 2, 2.5. So I went right 2 and then up 2.5 spaces. Its radius was only 2. So I went up 2, right 2, left 2, and down 2. And the blue circle is my new dilated circle. It's half as big as the original circle because of that scale factor of 1/2. So we've noted a translation, which is moving the circle or sliding it, only affects the center, not the radius. The dilation, which makes the circle bigger or smaller, affects both the center and the radius. Don't forget, for the center is the opposite of what you have inside of your parentheses.